So today we're going to start chapter 2. We made our unit circle yesterday. Keep it. Don't lose it. But again, it's an aid to make sure you're right. It is not a crutch. What you should be doing, if you're doing finding any, the sine, cosine, tangent of any of those angles on that circle, you should be using your triangles, or remember also, I would, and I have it on the board because I did it for geometry the other day. I don't like to make those triangles. They take too much time because I'm perfectionist on the lengths. I just write it like this. Can I see the whole triangle here? Yes, because this is opposite and this is adjacent and this is always the hypotenuse. And so 30, 60, 90 is 1 square root of 3 and 2. So opposite of 30 is 1, but adjacent is square root of 3 because 90 is always the hypotenuse. And then you just make a little and put 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So with those, you can do everything you need. So I've already been saying, well, in chapter 1, we learned like sine was y over r, right? And we still need to remember the y's and the r's because that tells me what quadrant we're in and if it's positive or negative. So it's important. But not all of our triangles are going to be in the coordinate plane. Most triangles, when we're solving triangles in real life that occur with problems, are not. So we don't need x, y's, and r's. But when you think adjacent, you should be thinking x. When you think opposite, you should be thinking y. When you think hypotenuse, you should think r. Okay? So definition 2 is just SOHCAHTOA, which you guys know. Yes? So we're just going to recap it. Remember, across from angle A is side what? A. Across from angle B is side B. Across from C is side C. Angles are capital, lowercase are sides. So SOHCAHTOA can only be used in right triangles. And I'm not even going to worry about cosecant, secant, or cotangent because those are just the what? They're just the reciprocals. Okay, so the sine of A is opposite over hypotenuse. Do I need to write out the words? Are you good with O's and H's and A's and H's? Okay, so what's opposite of A? A. And hypotenuse is C. And then cosine of A is A over H. So adjacent to A is B. And hypotenuse is still C. Tangent of A? Opposite over adjacent. And so we get A over B. So if I asked you the cosecant, you would tell me it's what? C over A. Secant is C over B. Cotangent is B over A. Okay, now I am going to do the sine of B next to here. And the cosine of B. Actually, you are going to do them. And then we're going to look at them for a second. After you get them done, I want you to look at them. Make an observation or two. You don't have to write it down, but just have something to say about it. Okay, did you get B over C, A over C, and B over A?
Yes.
Okay. What do you notice about them?
Sine and cosine are flipped.
Okay, so the sine of A is congruent to the sine of B, yeah?
Mm-hmm.
Or equal, those would be values. And the sine of B is equal to the cosine of A. And then cotangent, they're just reciprocals, right?
Yeah.
Well, what do I know about angle A and angle B? What is the relationship? If I would add those two angles together, they would always equal what? They'd always equal 90. Why? With the right triangle, and C is our right angle, right? So we only have 90 degrees left to mess with. So you always wonder why, like, I always did, why they're named what they are. Well, it's sine and cosine, secant and cosecant, and tangent and cotangent because of the fact that they are called cofunctions. Okay, so what that means is that they will be equal, and the sine of A will be equivalent to the cosine of B. And what do we know about A and B? They are what? They equal 90, so what's the word form? Complementary. Okay? So the cofunction theorem says that the trig functions of an angle is always equal to the cofunction of the complementary angle. So and it says trigonometric, but I'm going to say trig function. Of an angle is always equal to the cofunction of the complement of the angle. So what that means to us, sorry, forget what I'm writing on paper, I gotta move it up, is the sine of what is equal to the cosine of 30. So a trig function of an angle is always equal to the cofunction of the complement of the angle. So what's the complement to 30? 60. The tangent of y is equal to the, what's its cofunction? Cotangent of what? How did we get 60? So you took 90 minus 30, right? So how are we going to get this one?
90 minus y.
90 minus y. The secant of 75 degrees is equal to what? What's its cofunction? The cosecant, bless you,
15 degrees.
of 15 degrees. Okay, so I told you you had to be able to figure out sine, cosine, tangent, and all that kind of fun stuff of all those angles, right? So let's just do a couple that I'll throw out at you. The cosine of 30 degrees. So our circle's there to check our work, but we want to visualize it, think about it, whatever. Okay? So cosine is what over what? What part of the triangle? Opposite, adjacent, hypotenuse. Cosine is
Question you asked slipped out my ear.
adjacent over hypotenuse. Yes? Okay, so opposite of 30 is 1. You all know that, right? So what does that make adjacent? Square root of 3. There's only 3 things in the 30, 60, 90 triangle, right? 1, square root of 3, and 2. So the hypotenuse is always the hypotenuse, and if it's not opposite, it has to be what? Adjacent. So if I know opposite of 30 is 1, then the adjacent is square root of 3, and hypotenuse is 2. I always, when you guys ask me a question, I'll be like, okay, so I know that the opposite is 1, so square root of 3 over 2. I don't remember square root of 3 is the adjacent to 30 because that's not important to me. What the most important thing is what's opposite of 30, correct? Because that's how I would place it. Okay? So sine of, somebody give me an angle. One will know. We'll do 60 and then we'll do 45 on tangent. Okay, so sine is 60. So sine is what over what? Opposite over hypotenuse. So opposite of 60 is square root of 3. Hypotenuse is 2. Now, why are these answers equal? Because 30 and 60 are what? Complementary, and sine and cosine are cofunctions. So tangent of 45. Tangent is what over what? Opposite over adjacent. So that's another thing we got to get down, right? Well, what's opposite of 45? What's adjacent to 45? So square root of 2 over the square root of 2 is 1. I tell you on the quiz, if you write square root of 2 over square root of 2, you are wrong. That answer is what? 1. Well, yeah, but it's 1. There's no even rationalizing it. Okay, makes sense. They're going to have tables, and they're going to say, do it without a calculator. Well, do you need a calculator? No. It's going to say, do it with a calculator. So what are you going to do? Do it with a calculator. Okay. Cosine squared of 30 degrees plus sine squared of 30 degrees is 1. So we need to show it's true. I've told you that's the Pythagorean identity, correct? Mm-hmm. Okay, I've told you it was true. We did the math and found it, right? But now you got to prove it with numbers. So this means I do this cosine of 30 and then I square it, right? We can't square the function. So cosine of 30, adjacent to 30, or opposite 30 is 1. So adjacent is, so I have square root of 3 over 2 squared plus opposite of 30 is no 1 over 2 squared. Well, 3 over 4 plus 1 over 4, which is 1. Which you can do 4 over 4, but I can go for 1 there. Oh, and I had to show that, so that's something I got to put a box on, right? I need to give you guys this test back. I'd like to do it at one time, though. Okay, so I'm going to let you guys do this one. So cosine squared of 45 degrees plus sine squared of 45 degrees equals 1. Those parentheses are important, guys. I can show you an example if somebody didn't, and it was horrible. Oh, gross. Okay, 1 equaled 1. Okay, are these parentheses important? Yeah, because without them, the square is only on the numerator, right? So parentheses do matter. I want to show you a problem that I was dealing with the other day. Okay, the problem is right here. This right here. And it's calculus, and that's besides the point. But I have 10 cosecant negative 2x cotangent negative 2x times e to the cosecant negative 2x. Okay, there are no parentheses there, are there? So there's no of. I'm not saying of anything, am I? And can I have just cosecant randomly there? No. Once I do this, I have the cosecant of negative 2x, don't I? And I have the cotangent of negative 2x. And I have the cosecant of negative 2x again. It completely changes your problem. Parentheses are important. Okay, more examples. We're just using the stuff that we know. Okay, I'm going to tell you x is 30 degrees, y equals 45 degrees, and then it says, and each of the expressions that follow, let these be, then simplify the expression as much as possible. So I have a sine of x. And I will tell you, your book does not put parentheses, put them. Okay? So a sine of x, not a. That is a 2. Not an a. I need to. I'm like, it can't be a because a is the problem. Okay, so what do I need to do?
Plug in the 30.
Plug in the 30. So I have 2 sine of 30. Okay, well, sine is opposite over hypotenuse, yes? Opposite of 30 is?
1.
1. Gotta get those. They're right on the board.
I know.
Okay, so it's 1. Hypotenuse is 2. So 1/2 of 2 is? 1.
1/4. Oh. 1/2. Oh. My bad.
Okay, sine Now, this is how they have it written in the book. Sine 2y. My brain says sine multiplied by 2y, doesn't yours?
Yeah.
Okay, but it's not sine 2y, it's sine of 2y. Those parentheses say of. That's the word. So what do?
Plug in 45 and
Plug in 45. So I have sine of 2 times 45, which is sine of 90. Okay, so 90 is up here. Yes?
Yeah.
What's that coordinate up there?
0, 1.
0, 1. And sine is y. Yes?
Following
So what's the
students
Y?
need to report to the library with
Come on.
their laptop.
Now,
Following
you
students
saw that
need
I
to
just
report to
went
the
from
library with their laptop.
opposite adjacent hypotenuse
Read the lobby,
to x, y's, and r's.
President
Just switched
Nick
back and
Morgan,
forth. Should you get to
Amy
that point?
Garrett,
Yes, you should just.
Jasmine
Should
Bell,
one more on your own.
Noah Troxel, Josh Upton.
4 sine
Again, read and lobby.
of
Linda
3x
Hall,
minus
Nick
90
Morgan,
degrees.
Damian Parrott, Jazz Shell, Axel Seaman, Noah Troxel, Josh Upton, report to the library with your laptop.
Did you get 4 sine of 0 degrees?
You leave it like that?
Nope. So I'm thinking my quadrantals again, yes?
Yeah.
So 0 degrees, what's my point?
1, 0,
1, 0. And sine is which one of those?
X. I mean, Y.
Y. And so it's 4 times what?
0,
So the answer is
0.
0. You noticed I worked down? Work down. I think we're it. In your book, in your notes, it has little tables and stuff, but you're gonna have a nice 61. Oh, you don't, I didn't assign 61.
You can't sign it now.
Okay, fine.